So, hi everyone. My name's Alex. I'm a software engineer at PwC. I work in the threat intelligence team, and a lot of my job recently has been about building a TAXII server, since it looks like a lot of people love TAXII. So that's what this talk is going to be about, how you build one and why it's cool. So to kick things off, I appreciate not everybody might be familiar with TAXII and sticks, which are the two things I'm going to focus on today. And this is kind of why I think it's worth paying attention to and hopefully might be of use to you. So if you're an analyst looking at alerts, or maybe you work in something like detection engineering, TAXII can probably be your friend, because it will help get threat intelligence data into a SIEM, so into something like Splunk or something like Sentinel pretty easily. So you can get alerts on IPs, URLs, things like that. The other thing which you might find quite helpful is that when you do get an alert, you will, with a TAXII server, get much richer alert data. So if you're thinking of just the IP pinging an alert, with a TAXII server, you might also get what's the confidence on that alert, when is it valid until, when's it from, things like that are going to hopefully help reduce alert fatigue, make your life a little bit easier. And then you're also going to get richer context. So again, suppose you're in Sentinel, you get an alert pinging up, and it's your job to figure out, what do I do with this? Is this important or not? Very easy in a TAXII server to then look at everything else associated with that campaign. So from that IP, you can get what are the hashes associated with that attack campaign, what are the domains, what are the URLs, and you can also then look up some other richer data. In the way I've implemented this server, you could straight away go to a threat intelligence report. So I think this is cool. It kind of flips instead of going from report to indicators, you can kind of go from indicators straight to the context, and that's all automated in your SIEM. So just to break down, the two main concepts here are TAXII, which is an acronym for Trusted Automated Exchange of Indicator Information. That obviously sounds quite abstract. I would think of that as just how you share and send data to people. And then you also need sticks, which is the format. So if TAXII is how we share and send data, then sticks is the format that we have to send the data in. And it's really just a way of making indicators machine readable. So say you've got something like an IP, how can we kind of mix that up into basically a flavor of JSON that means all computers can read it the same way? That's still sounding a little bit abstract. I'm going to pop on to the slide after this to a more concrete example, but just a little bit more on sticks. That stands for Structured Threat Information Expression, and I would really think of it as a serialization format. So again, just a flavor of JSON developed by Oasis, I think an American NGO that made sticks, with MITRE, who will crop up a little bit later in the talk. So point being, it's a kind of recognized, standardized format. And then in Python, this is what it looks like to create an indicator in sticks. So here you're just instantiating a class, giving it a bunch of keyword arguments, and this can all get exported basically as JSON later. And you might see already here some of the things I talked about that were cool for richer alerts. So things like the valid from value, when it was created, when it was last modified, and then you can get things like a description and a name. You can build on top of this and do many more complex things, have relationships between different types of objects in sticks, give them TLP red values, TLP amber values, lots of kind of fun stuff like that. So now that hopefully all makes sense, just a quick recap. Sticks is the way we format the data. TAXII is how we share it and send it to people. In about, hopefully, 12 minutes left of my talk, I'm going to run through how do you actually make this. TAXII is a very big topic, so this is going to be just the tip of the iceberg, but these were the three main challenges I had in actually implementing this. So one was getting your data into sticks. In my experience, a lot of organizations probably have threat intelligence data in quite an unstructured format. Probably you've dumped it into some kind of NoSQL database, something like Mongo, something like Elasticsearch. That's quite cool at the time. If you're an analyst, you can just chuck it in and forget about it. That's a real problem, though, if you have my job and are trying to get it into sticks. Sticks is very opinionated and really needs a specific format. That's challenge one. Challenge two, say you've got 100 gigabytes of data to convert. You probably don't, ideally you don't want to convert that and have to store it in another database, because then you have to pay for that extra database. So a neater way of doing this is you want to convert all the data from sticks in something like Elasticsearch and do that on the fly. So you can keep your old database that presumably integrates with all of your existing systems. You don't have to create a new one, and you can just send it straight into sticks. But for that to work, it has to be pretty reliable, because again, remember, sticks is very opinionated. And it's also going to have to be performant, because a taxi server is, at least in my use case, and presumably most of them, is going to be something people are going to want to hit fairly regularly if they're getting it into something like Splunk or something like Sentinel. So how are you going to do that so it scales? And then challenge 3, by this point, you've only got stuff into sticks. So we haven't actually got it into TAXII, which is the protocol for sharing stuff. So that's the kind of third one. So I'm going to start just with that first challenge. How do you get stuff into sticks? This is a sort of made-up example of the kind of thing I would deal with at work. This is what an Elasticsearch document roughly looks like. So if you might have forgotten, but if you remember on the slide I was showing in sticks for producing a sticks object in Python, that looks pretty different to this. First of all, we've got some nested keys under that source key there. We've got a bunch of keys like index and type that don't exist in sticks. That ID string is actually not UUID compliant. It's pretty long. So there are a whole bunch of things we have to do that is going to convert this into something reliable. But we do have the kind of data there in all the values that we want to keep. So Pydantic is the Python library I'm using here that I would really recommend for this. This does quite a good job of solving challenges 1 and 2, getting data into sticks and getting it done reliably and in a way that can scale. The main reason it's good for converting stuff into sticks is that Pydantic does something very cool, which is that it makes Python check types at runtime. So Python normally is not a statically typed language, but you can put in type hints. But when Python starts running in a Python interpreter, it doesn't check those type hints. If you use Pydantic, it does check the type hints, which means we're going to get a lot more correctness. That's useful for sticks because we need stuff to be reliably in sticks or it's going to break. It's not going to work in the TAXII server. And the other very cool thing about Pydantic is that it is super, super performant. So it really solves that problem of doing things on the fly, getting stuff straight out of something like Mongo, something like Elasticsearch into sticks, removes the need to create a new database. And then also you can see here in that validated decorated method there, you can do quite a lot of pre-processing. So it will help you convert stuff into sticks for that way too. So we've now hopefully solved challenges 1 and 2, getting stuff into sticks reliably and at scale. And now we have to get it into TAXII. The TAXII spec is very, very long. I haven't counted the pages. I've just looked at the HTML website, but I think it's probably several hundred pages and quite hard to read. So I would basically recommend don't read the spec. And instead, I would take basically have a look at the code on people who've written TAXII servers. So Oasis, who came up with the stick spec, have got one called Medallion. I would really recommend taking a look at. And then you can copy and paste the responses from that server and write your TAXII server until you hit those responses. So the idea here is skip reading the spec, basically take what you know are known good responses, and then write your code until it hits those. And so that's basically what I'm doing here. I have here copied and pasted some responses from manifest query responses, which are part of the TAXII protocol, from someone else's server. I know they're good. And then I've just written a test suite here that hits those endpoints on my server. And I just wrote this until these tests pass. That has all the tests on my TAXII server. So there's a few things we don't need. But really the idea here is you can save a lot of time, and you also get to call yourself a test-driven developer. This is test-driven development. And then if you get into trouble later, you can go and read the spec and debug things. But I personally found this a lot more fun and a lot faster. So now we've kind of got an idea of how we can get stuff into sticks and share it in TAXII. What does this actually look like if you're a customer? The bit I was saying at the start, how do we get richer alerts with more context? What's it like to actually use? What's the point of this? And so this is in Sentinel, what it would look like if you're adding a TAXII server. So if you go into Sentinel, you then go to Data Connectors page. From there, you can pick TAXII. And it's pretty simple. You just have to put in these sort of 4 or 5 values. The first one is just something you can come up with. I've just called it campaigns, but you could name it whatever you want to remember it by. And then TAXII servers typically use HTTP basic auth. You can change the auth method if you want. But if you use that default, it makes life pretty easy. You just put the URL you want to hit, a username and a password, and then how often you want to poll the indicators. And really, that's it. So it should take about 2 minutes to configure if you're a customer and you've built the TAXII server correctly for them. And then what you get at the end is this. This is what the view looks like in Sentinel. So here on my left, your right, you will see some of that richer alert context, hopefully. You can see there's a confidence value of 80 for that IP. You've got when it was created, when it's valid until. There's a description value there, which is the name of the threat actor that my team tracks for that IP, but that could be anything really that you want to call it. And then the other thing that is, the main thing that I think is pretty cool here is if you see on the far left of the screen, the names, those names refer to our threat intelligence reports, those CTO TIB values. Each one of those is a unique identifier for a report. So if you want to pivot from that IP, suppose that IP is pinged an alert and get the campaign that's associated with, you can literally just copy and paste the CTO TIB value for that IP into Sentinel, and then you'll be able to get all the IPs, URLs, domains, and hashes, all the indicators associated with that campaign straight off the bat. And then if you were one of our clients, you could hit our API or hit our portal and read the report and see what's in it. So very, very fast way to get context for the person kind of monitoring Sentinel that should make their life a lot easier. So that's kind of really what we've built. I'm just going to wrap things up now. These are a couple of resources that I was speaking about. So the first two there are some example TAXII servers. This is the bit where I would say skip reading the spec, have a look at how they've done it, and kind of write code until you hit their responses. First one's by Oasis, who came up with the stick spec, so very reliable. That's the one I used. OpenTAXI is also quite good. Their sort of that eclectic IQ team are very good at threat intel. And then if you want to look a bit more at sticks, I would recommend going to the examples there and just having a look at stuff probably in Python. I find that a bit easier than reading the docs. And just to summarize, the three main challenges you have in this are how to get stuff into sticks, how to then convert that reliably and at scale, and then how to get that all into TAXII. That's quite a big job in itself to get it into that protocol to share things. And that is about it for me. So thank you very much for listening. And I guess
anyone, any questions?
Thanks for the talk. It was interesting. How would you contrast something like Sticks to OpenIOC in terms of sharing threat intelligence information? Obviously, OpenIOC is a bit older, but there's a draft version of an updated version.
I don't know that spec that well, to be honest, because I've mostly focused on Sticks. I guess it seems to me like the benefit of Sticks is that it seems to be what a lot of people want because you can integrate it into Sentinel. That's sort of been the main use case for me at work, that people want a way to pull stuff in straight away. I don't know if that's possible with that other format, but I know that most of the seams that people are using have a TAXII is like the easiest way to get it in, and for that you have to use Sticks. So so I don't really have a more thorough answer.
Then thank you very much.
Thanks.